Okay, we should be working. I'll try my best not to keep my mouth too close to this. Alright, so here we go. So this guy, when you looked at the limit, it should have been going towards negative 0.5. So how do I know this? How did I know it before looking at a physical table? The same way that you will know it without looking at a physical table. Ty, what do you notice? Yeah, from the equation. You said some important things. The powers were the same. You said the word horizontal asymptote. Those are all things that we're going to use. That is exactly what I used to figure it out. So, if you look here, we're going to go back. This one, the numerator is greater than the denominator. The second one, the denominator is greater than the numerator. And then the last one, they were equal. The numerator was equal to the denominator. And so those are really the only three horizontal asymptote rules you're going to need to know. You guys actually did long division, synthetic division to find slant asymptotes. We won't actually do that. You just have to know that it's there. So what do I mean by that? These are all rational functions, so I'm going to redefine, which is actually right below, but this is a rational function where g of x and h of x are polynomials. Okay? Rational functions, what do you remember about them? They have horizontal asymptotes. You probably remember also most of them have vertical asymptotes, but we're going to use the horizontal asymptotes. So on the next page, we're going to summarize the ones you have to know. So if the higher power is in the denominator, so this is the denominator, let's do y is equal to x squared plus 5 over 4 minus x cubed. So the denominator is greater. Anytime that happens, you automatically know that the horizontal asymptote is y equal to 0. Okay? That's how I knew before you guys graphed or did a table. Well, what else does that tell us? Well, it also tells us that if I take the limit as x goes to negative infinity, it will be 0. And I also know that the limit as x goes to positive infinity will also be 0. That's the great thing about knowing the horizontal asymptote. The horizontal asymptote will give you the end behavior. Now, real quickly, did I mention factoring today? No. Did I mention simplifying? No. Those rules you use for limits at a number. Limit as x goes to 2. Limit as x goes to 5. We do the rules. We try substitution. We try factoring. We try simplifying. When we do end behavior, limits to infinity, we talk about horizontal asymptotes. Completely different. The middle one? So we want the same power. So let's do x squared plus 5 up top. And we can do negative 3x squared minus 2. Well, if they're the same power, the horizontal asymptote is the ratio of the coefficients. So I'm going to circle them here. The ratio of the coefficients would be negative 1/3. And why is that helpful? Well, if you know this, then you can find the limits at negative and positive infinity. So in this case, just to save a little time, I'm going to do plus or minus infinity. So I know that that's true. Okay, I don't have to graph it. I don't need a calculator. I don't need to try to put infinity into the equation because no, that does not work for rational functions. I know that this will be true. And then when the power of g of x, which is the numerator, is greater, so let's do y is equal to x to the 5th minus 3x all over 4 minus 6x cubed. Trying to do smaller equations so they fit. Well, what happens with those? There is no horizontal asymptote. Some of you are going to think slant asymptote, but this one's not even a slant asymptote. And I don't care about the slant. I care about if there's a horizontal asymptote or if there isn't. Slant gets put into a category. The category is not horizontal. These are not horizontal, but what we're going to do, we're going to do an end behavior. And how do we do end behavior? Same as we did up here. Circle the highest power on top, the highest power term on bottom, and make a fraction. And this is the only time you'll hear me use the word simplify for these. You're going to simplify this guy. So I get negative 1/6 x squared. Does that look much simpler? Do we know what that graph looks like? Squared. Draw it in the air. Now I'm scared that you don't know. It's negative, so draw it again in the air. All right. So, facing down. So if I show you this graph and I ask you what's the limit as x goes to negative infinity, can you tell me the answer? Which side's negative infinity, left side or right side? Left side. So what is the limit as x goes to negative infinity? It is negative infinity. And what about positive infinity? It's also negative infinity. Well, guess what? You also found the end behavior of the original function. That right there is an end behavior model. Sorry. End behavior model. What that tells me is this is very complicated. I can simplify it by circling highest power numerator, highest power denominator, right here. Simplify that down and then draw its graph. And that graph here has the same end behavior as the complicated graph you started with. All right? So why are horizontal asymptotes helpful to find end behavior? Because they are the same thing. They're the same. A horizontal asymptote is end behavior. So I'm going to give you the actual definition of a horizontal asymptote. And this definition you must physically memorize. What's the other one that you've learned so far that you had to physically memorize? Limit. So now you have two definitions that you must know. Limit being the first one, horizontal asymptote being the second one. I won't even quiz you right now because your eyes are like, uh-oh. Okay, so this weekend, I would memorize them. All right, horizontal asymptote. Let me use a better color here. Use purple, sure. All right, so if y equals k is the horizontal asymptote of f of x, then the limit as x goes to negative infinity of f of x equals k, or the limit as x goes to positive infinity of f of x equals k, or both. I'll add that in for you. If you have a horizontal asymptote, it will be the end behavior. These two statements here are our end behavior statements. So if I know that a function, especially a rational function, if I say a rational function has a horizontal asymptote of 6, then you guys should be able to tell me, oh, the limit as x goes to negative infinity of the function is 6. Oh, the limit as x goes to positive infinity of the function is 6, because they are the same. The horizontal asymptote makes the end behavior. Why would I ever put an or? Can someone think of a function that has a horizontal asymptote, but the limit doesn't go to the asymptote on both sides? A function, and I'll give you a hint, it is one of the basic functions that we had to do at the beginning, our very first day. Okay, Jamie? Log doesn't have a horizontal. Which one does? Exponential. An exponential function, do we say that it has a horizontal asymptote? Yes, but draw that in the air, it doesn't go on both sides. Okay, that's why the big or is here, for that reason. Okay? Find each of the limits below. Sure. So, you're going to negative infinity. Highest power is where? In the denominator. So since the highest power is in the denominator, we know the horizontal asymptote is y equals 0, which then tells me that the limit is 0. We did this one. Remember, when you're doing limits of compositions, you can actually put the limit in. In this case, we're doing 1 over infinity. What does that go towards? 0. Therefore, this is the same as sine of 0, which is 0. All right. perfect timing. I think we're good. Remember, your homework is number 3. Also, actually, on Edmodo, I am going to do an assignment that you're going to turn in through Edmodo. The assignment is I'm going to finally give you guys my welcome letter. It tells you about me, and that I'm going to ask for you at some point during this 3-day weekend to type up a letter about yourself, because that's how I find out if you have siblings or if you enjoy certain things or hate certain things or whatever you want to tell me about your whole entire life story. Okay? So I'll give you my life story, and you will give me whatever you'd like to share about your life story. I decided to wait until now because I feel like first day you guys are a little more shy. Now we know each other a little bit better. You'll feel more comfortable to share. Okay? All right.